Okay, today we will do the image formations in a spherical lens. Okay, how the images are formed in a spherical lens, that we will do today. See, before doing that, we will know about some specific parts of a spherical lens. Okay, parts of a spherical lens. We will do the parts of a spherical lens. Okay, suppose I have a lens like this. Suppose I have a lens like this, and suppose this be the principal axis. Okay, we will learn about what is a principal axis later on. Now, if some rays come parallel to the lens, they will always pass through some point on the line. Okay, they will always pass through some point on the line. This point is known as focal point. Okay, now when the parallel lines come and they intersect, the focal point that will be formed is known as second focal point. Okay, so when the parallel lines will come and meet, they will meet at a focal point that is known as second focal point. Okay, see again, suppose the parallel lines are coming and they are falling on a concave lens. Suppose these are concave lens and the parallel lines are coming and falling on a concave lens. Okay, so suppose a parallel line is coming in this way and it is falling on the lens. It is coming in this way and it is falling on the lens. Okay, what we will see is that it will get refracted. This one will also get refracted, and after refraction, if we extend the refracted parts, they will meet at a point. That means it will appear as if the rays of light are diverging from this point. This point is also a focal point, and this is known as the second focal point. Okay, this is the second focal point. I hope the concept is clear. Now we must learn and understand one thing clearly, that in case of a convex lens, the rays of light will actually meet at this point. In case of a concave lens, the rays of light will diverge out from this point. That means if we extend them, they will meet at this point. Okay, so rays of light actually meet in case of a convex lens. Rays of light don't meet in case of a concave lens. They appear to diverge out from a point. But the whole concept lies here, that as the rays of light are coming parallel, then after diffraction, whether they are directly meeting or they are not meeting, whatever is the case, after refraction, whether they are directly meeting or they are not at all meeting, but if they are parallel to each other, then it will either appear to or will meet at some point the second focal point. Acha. Now we will do the second concept. Suppose we have a lens.
Sir?
Yes, tell me.
Sir, convex lens have to meet at a point, but the convex lens have to diverge.
In case of concave lens, a ray of light will of course diverge. Okay, but in case of a concave lens, the ray of light In case of a convex lens, the ray of light will of course converge. In case of a concave lens, the rays of light will diverge. Is that clear? Convex, converge, concave, diverge. Okay? Okay.
Yes, sir.
Now, understand it in this way. Suppose I am having a point here. Okay? Suppose a ray of light emerge out from here and they move out parallel. So there is a point on this dotted black line where if I place an object, after refraction the rays of light will be parallel to each other. Okay? In the same way, I can think in case of a concave lens that if a ray of light comes in such a way, that it comes towards this direction, then after refraction it will move out parallel to the principal axis. Okay, so there is always a point on the principal axis from where if a ray of light comes, in case of convex, if a ray of light comes, it will move out parallel, and it may happen that in case of concave, if the rays of light come and try to meet towards a point, they will move out parallel to each other. Okay, so we have heard of both of the cases and we understood them. So these are parts of a spherical lens in terms of the type of ray that is coming towards it. Now, so this point that we find here is also a focal point. We call this focal point as the first focal point. Okay, in case of concave also we will call this as a focal point and as first focal point. Okay, so we have got the idea of focal point. Now suppose, let us get into a bit more concept. See, suppose I am making a convex lens. Suppose this is one side and this is the other side. Can you understand that its one side is more curved than the other side? Can you understand that? That one side of this lens is more curved than the other side of the lens. That means if I take this surface as surface 1 and this one as surface 2, what we will find is that the center of curvature of surface 1 will be somewhere here, and the center of curvature of surface 2 will be somewhere here. Is that clear? But remember, a lens has two focal points, the first focal point and the second focal point. Remember that whichever the case may be, this lens will have the focal points equidistant from each other. Suppose this is F, this is F. If this is F1, this will be F2. But the distance from the middle of the lens to F2 and F1 is same. Is the concept clear? So it doesn't matter whether the center of curvatures are different or not, but the focal length is same for a lens. Tell me all of you, is this concept clear to you?
Sir, could you repeat this one again?
Okay. You have a lens like this. You have a lens like this. Okay. Now if you extend it then you will find out that it has two center of curvatures. One center of curvature with respect to this surface, another one with respect to this surface. Suppose this is surface 1, this is surface 2, so center of curvature of surface 1 will be C1, center of curvature of surface 2 will be C2. Okay. If I ask you about the radius of curvature, C2 will have a radius from here to here, C1 will have a radius from here to here. Okay. So this will be R1, this will be R2. Is that clear? So this one is R1, yes, and this one is R2. Okay. Now, if we see the cases, we can understand that R1 may not be equal to R2. But if I find out the focal lengths, suppose this be F2 and this be F1, F1 will be up to this, F2 will be up to this, the lens will have same focal length on either side of it. Is it clear now? The lens will have the same focal length on either side of it. So it does not matter where is the center of curvature. It does not matter whether the radius of curvature is more or less on whichever side, but it matters that the focal length will be same. And the same happens with the concave lens. Okay. Now, let us make an idea clear. Let us make an idea clear, okay? Which states that suppose I have a lens. Okay, I have this lens. Now, the line joining the two center of curvatures, if this is surface 1, surface 2, this is center of curvature 1, this is center of curvature 2. The line joining the two center of curvatures is known as principal axis. This one is known as principal axis. The line joining the two center of curvatures is known as principal axis. Okay. And if I draw a line midway between them such that they cut out at some point. Now this point is not necessarily the midpoint. Okay, we'll learn about this, but geometrically if we think that if there is a line which is midway between them, we can call this line as optical center. The real definition of optical center is different, I'm telling you that. Okay. Now, so this is principal axis, this is optical center. Okay. Now we will get a bit detail into optical center. What is optical center? Suppose I have a thin lens. I have a thin lens. To understand optical center, we need to have a thin lens. What is a thin lens? A thin lens has a very large radius of curvature. That means its curvature will be very less. So suppose I have a thin lens. The lens is like this. Okay, this is my thin lens. This is a thin convex lens. Now, an optical center is a point such that if light ray comes towards the optical center, it will pass undeviated. So optical center is a point on which if a light ray falls, that light ray will pass undeviated. Okay. Suppose I have a thin concave lens. Okay, I have a thin concave lens. In that case also, the optical center will be a point through which if a light ray falls, that light ray will pass undeviated. Is the concept clear to all of you?
Yes, sir.
Okay. Now that was the case of a thin lens. But yes, tell me again.
So repeat the concept again.
See, optical center is a point. See, light ray is coming towards this point, right? Is the light ray bending? Is
No,
the light
sir.
ray bending? Is anything happen? It is coming straight and it is going away straight, right? This light ray is coming straight and this light ray is going away straight. In this case also the light ray is coming straight and it is also going away straight. So when both of the light rays are coming straight and they are going away straight, that means that these light rays are passing through a point on the principal axis. That point is known as optical center. If they pass undeviated, then that point is optical center. Is that clear, all of you?
Yes, sir.
Okay. So
So what do you mean by undeviated?
undeviated means they will not bend. What happened in the previous diagram? In the previous diagram, it happened that if a ray of light was coming in this direction, it was actually bending, right? But is it bending here? No. Is it bending here? No. So as it is not bending in both of the cases, that means the ray of light is passing undeviated in both of the cases, but it is deviating in this case. Okay? Okay. Now we will understand the case of a thick lens. See, what happens in case of a thick lens? Now let us draw a thick lens. Let this be a thick lens. Okay, let this one be a thick lens. Okay, suppose, let me draw the principal axis. This is the principal axis. Suppose a ray of light is coming like this. A ray of light is coming like this. What will happen is that it will get refracted and then it will again get refracted. Then it will pass in this direction. So what is happening is that the incident ray and this ray, both of these rays are parallel to each other. The incident ray and the emergent ray are parallel to each other. Okay, then if these two rays are parallel to each other, then the point on the principal axis from where the light ray passes is known as optical center. Okay, suppose I take another example. Suppose I take this example. Suppose I take this example. Okay, now if I have a ray of light like this, if I have a ray of light like this, okay, let me draw it more oblique. Let I have a ray of light falling at this point like this, then it will pass through some point, then again it will move parallel to the incident direction. Okay, then again the point through which the ray of light is passing on the principal axis, this is the optical center. So what is optical center? Optical center is any point on the principal axis such that the incident ray and the emergent ray, are parallel to each other. So it is any point on the principal axis for which the incident ray and the emergent ray are parallel to each other. Is the concept clear to all of you? Turn on your audio and tell me, is the concept clear to all of you?
Yes, sir.
Okay.
Yes, sir.
Now
The optical rays are different in the different lenses like thick lens and thin lens.
I cannot understand. Tell me again. See, do you see the curvature of the lens and the mid portion of the lens? See, the mid portion of the lens is so thick, and mid portion of this lens is also so thick, right? This kind of lens whose mid portion is so thick, they are known as thick lens. Is the idea clear?
So, but these two lenses are convex and concave lens, as we know that if a rays come to it and they just converge in a point, but in these two lenses there is nothing that.
What is converge to a point? I cannot understand.
Sir, in a convex lens, when a ray was just coming from a point, it was just converging in a point, so it was not happening in this.
Why will it happen? See, if I send a ray in this direction, understand it properly. Suppose I am sending a ray in this direction, okay? Then it will go in this direction. If I send a ray in this direction, if I send a ray parallel to the principal axis, then it will go in this direction. That means this is a point on the principal axis through which a ray will pass if it comes parallel to the principal axis, right? But
Yes.
then this point is known as focal point. But the idea of optical center is different. The idea of optical center is that when a ray of light comes such that it passes through the principal axis and emerges out parallel to the incident direction, then we will call it as a thick lens. Is the idea clear? We will call it as a thick lens only when after diffraction it will pass through the principal axis inside of the lens, and the two rays will be parallel to each other. Okay? Yes, if anyone is having any question, ask me.
Sir, in the optical, there was the rays was coming from through it, sir.
The ray is coming and passing through the lens. See, it is not necessary that the optical center will be in between the lens. That is also not necessary. But it is necessary that when the ray of light will come, the incident and the emergent directions will be parallel to each other. See, if I extend it, see this one and this one, they are parallel to each other, right? Both of the rays, this green one and this green one, they are parallel to each other, right?
Yes, sir.
So this is what I am asking you, that if the incident and the emergent rays are parallel to each other, in that case only the ray will pass through the lens, cutting a point on the principal axis. That point will be known as optical center. Okay. Now
sir.
we will understand about. Now is it clear to all of you now?
Yes, sir.
Okay. Now we will understand what do we mean by just wait. Now we will understand. Okay, let us do some rules of refraction of light through a lens. Rules of diffraction of light through a lens. Okay, see, now we will do the first rule number 1. We have already done rule 1. Rule 1 says that if there is a convex lens, then we will first mark the position as, see how I am marking. This is focal point 2, equal distance, this is focal point 1, double of this distance, this is 2 focal point 2, double of this distance, that is 2 focal point 1. Okay, now it is saying that if a ray of light comes parallel to the principal axis, then after diffraction this ray will pass through the second focal point. Okay, so write down the rule. This rule says if a ray of light incident parallel to the principal axis, if a ray of light incident parallel to the principal axis passes through the second focal point after refraction. Okay, if a ray of light incident parallel to the principal axis passes through the second focal point after diffraction. Okay, what will happen if I replace this one with a concave lens? What will happen if I replace this one with a concave lens? See, suppose this is a concave lens and I am replacing it with a concave lens. Okay, this is a concave lens, I am replacing it with a concave lens, and suppose a ray of light is passing parallel to the principal axis and falling on the lens, then also it will reflect in such a direction that after extending it backwards it will pass through the second focal point. So we know we have two focal points, one is the first focal point, another one is the second focal point. So in case of concave lens, after refraction it will go in such a direction that if we extend it, it will pass through the second focal point. So how will I modify this one for concave? If a ray of light incident parallel to the principal axis passes, you can write axis diverges such that axis appears to diverge from the second focal point. See, it appears to diverge from the second focal point. Okay, now we will do the second thing. Rule 2. See, rule 2 states that suppose this is a lens. Okay, rule 2 states that if a ray of light emerges out to the first focal point, then after refraction it will move parallel to the principal axis. So rule 2 states that if a ray of light emerges out from first focal point, then it will pass parallel to the principal axis after diffraction. Okay, if a ray of light emerges out from first focal point, then it will pass parallel to the principal axis after refraction. Okay, now what will happen if I replace this one with a concave lens? Suppose I am replacing this one with a concave lens. Okay, now in case of concave lens, the first focal point is here. Okay, this is the first focal point. Now suppose a ray of light is coming towards the first focal point. What is happening? A ray of light is coming towards the first focal point. Then after refraction, it will move out parallel to the principal axis. Okay. So for concave, if a ray of light appears to come towards the first focal point, if a ray of light appears to come towards first focal point, then it will pass parallel to the principal axis after refraction. Okay, now tell me, are we clear about these two laws? Are we clear about these two laws? Hello?
Yes, sir.
Okay.
Yes, sir.
Okay, rule number
Yes,
3.
sir.
Okay, rule number 3. Rule number 3.
Sir, could you just wait for a minute?
Yeah, just 1 minute only, because we have to end it before time. Rule number 3. Rule 3 states that suppose you have a convex lens. Okay, now what happens is that suppose you pass any ray directed towards the optical center, the ray of light will pass out undeviated. So if you pass any ray directed towards the optical center, then the ray of light after refraction will pass undeviated. And this same thing applies to the concave lens also, that if I just change this lens, however, and make it look like this, then also the whole scenario will remain the same. Okay, this is the optical center. I am asking all of you, is the concept clear to all of you?
Yes, sir.
Okay,
Yes, sir.
so we have got this idea clearly about the 3 rules. Now for today we will just,
Sir?
yes, tell me.
Sir, in the rule 3, the lenses are thick or thin?
In this rule we will consider always, whenever we are doing the ray diagrams, all the lenses that we will consider are absolutely thin lens, and all of the rays that are falling on the lens surface are very close to the principal axis. Is that clear?
Yes, sir.
These are the 2 approximations that we must take before drawing the images. So our class is over for today. It's 3:54. You are having class from 4.